Let's move on to the scientific method. So over here we have a table that's actually taken from your textbook, Steps in the Scientific Method. You guys have heard these before. However, this is going to be a pretty simplified version of it. Making observations. One of the things that's kind of obvious, you have to see stuff. You have to be paying attention. And if you have your face in your iPad, if you have your face in your video games and your cell phone, I sound pretty old right now, but if you're only interacting with that electronic source, you won't be able to see the world around you. And if you can't see the world around you, you will make no observations. Now, specific to the field of science, or should I say empirical science, to be very specific, natural science, observations may be qualitative, right? For example, the sky is blue, quality. It stands for quality. What is the quality of the sky that you can describe? It is blue. Water is in the liquid state. Or it can be quantitative, which is quantity, which is a number. For example, the boiling point of water is 100 degrees Celsius. Right? A certain book weighs 2 kilograms. That's a number. That's a number. Then once we make these observations, we're going to formulate some sort of hypothesis as to explain the observation, why the observation is. So the observation is true. Observation is true. It exists. It's there. My hypothesis is going to be a possible, which means not necessarily probable. It doesn't have to be probable at all. Sometimes all we want to do is get rid of a possibility. We just want to make sure that it isn't the case because it's going to make the rest of our investigation more simple. And so it doesn't have to be a probable one. We're not trying to prove something. That's actually not what science does, is we disprove. That's truly what happens. So a hypothesis is a possible, not necessarily probable, but it's a possible explanation for an observation. Why that observation is so. For example, the sky is blue. It's an observation. My hypothesis is going to explain why the sky is blue. And it could be totally wrong. It might have a little bit of correct information in there, but I might have to change a certain portion of my hypothesis, and that's fine. That's what the hypothesis is for. And then in order to test that hypothesis, we're going to perform experiments. An experiment is carried out in order to test the hypothesis, like I just said. This involves gathering new information that enables a scientist to decide whether or not the hypothesis is valid. Now, it's very, very common that hypotheses are rejected. It's actually more common to reject a hypothesis than to accept it. But again, all we really do in science, strictly speaking, is disprove things. We don't prove anything. If you listen to scientists speak, if they're speaking the way they should, they'll use language that sounds something like this. The data suggests. This study shows. Right? It might seem like it's a little bit vague, but it's very important to understand that it is possible that it's actually not true, that the explanation is not truly descriptive of the cause. Because, truly speaking, we might not be able to even comprehend of the true nature of the cause, let alone describe it or test it. And so all we're doing is we're doing our best to interpret data to formulate a possible explanation for why something is. And because it's only a possible explanation, if it's ever shown to be incorrect or if it's ever disproven, we need to be willing to throw away the hypothesis with no emotional connection. Right? It's shown as incorrect. That's fine. Move on to the next thing because we are trying to learn things about the world. Now, performing experiments hasn't always been done. Yeah, this hasn't always been done. If we go back to ancient Greece during the time of the philosophers, they actually believed that mind experiments were superior to empirical experiments. And that might seem like it's silly, just if you imagine something in your head being better than doing something in real life. Let me remind you that a guy named Albert Einstein only did calculations, right? This guy, pretty important. I mean, if you go back and you actually study what Einstein did, what he's actually famous for, his first Nobel, his Nobel Prize, I should say, his Nobel Prize was for describing the photoelectric effect, explaining why the photoelectric effect was the way it was, and a particular thing that happened with the photoelectric effect. But he was not the one actually doing the experiments, right? The problem came when people were doing the experiments and they were getting data that they could not explain. Right? There's no hypothesis that they could come up with that would explain the data that they were taking in. And so Einstein just took that data and did calculations. He never actually did many experiments. So it's not that wacky that those Greek philosophers thought that doing something in their mind was superior. However, in today's science, which to be very, very strictly correct here, is known as an empirical science, which means numbers, or a natural science, something that we can observe and manipulate. So moving forward, a good experimental design coupled with repetition is key. This is the part that is nearly impossible to get in classes, right? To get in a normal chemistry lab, repetition. In real science, real leading edge science, every experiment, every lab is done time after time after time after time. So once we get to once we get to our, from our hypotheses to our experiments, then we have a theory. Hypotheses are assembled, meaning put together, in an attempt to explain why the what happened, right? Why the what happened. So here's my observation. Right? This is the thing that happened. This happens, right? This might be known as a law. For example, the law of gravitation. Objects with mass are always drawn to the center of another object's mass. So that always happens. It's never been seen that this doesn't happen. Now, why that happens, not necessarily as easy to describe. This is what happens, right? I throw this pin up in the air, it'll fall back down. Throw it up in the air, it'll fall back down. It's a description of what happened, and that will happen every single time. It's a law. It's been upgraded to a law. But the idea of why that happens, what about the natural universe causes that pin to go down after I throw it up? This is a theory. This is a theory of gravity, right? The explanation of why. Einstein had quite a bit to say on this, but it's still the theory of relativity. Theory of relativity. Now, these two terms are used very interchangeably. Models, we use models to explain natural phenomenon. When new evidence is found, the model changes. So we have this idea that explains the why, right? We explain why the what happened. And so we have this working model, a description of why. When we get new information, when we get new data, it might change our understanding of why the what happened. And so if our understanding of the why changes, then our model will have to change as well. And so the model changing is a good thing. It means that we've gained more understanding. As we go through a review of some famous chemists throughout history, we're going to see, especially with the atomic theory, we're going to see that we're not focusing on these people that they're wrong, that they were stupid. It's that over time, new information is gained, and we simply add to the collective pool of information as a species, and we become better because of it. And so a changing model is actually a good thing. It means that we learned something. So one of the first people to be considered a true chemist, right, was someone called Robert Boyle. And one of the things that he did is he did a lot of experiments with gas. Why? Because he loved to experiment with air. These types of people who were, kind of well off, you can kind of tell is a little bit of an aristocrat. But this person didn't live for a day-to-day paycheck, right? This person is not struggling to get by. And so this person had a hobby, like a lot of people did during this time. It was hot air ballooning. Right, they really like to do hot air balloons, and it was kind of like hot rods, back in the 50s. These people would take out these hot air balloons. They'd say who could make their balloon go higher, who could make their balloon go faster. They would actually race them, which might seem lame, but for back in the day, this was amazing. And so this was a hobby that he had, and in order to become better at his hobby, he started to study air. And he's known for doing several things. For example, creating the first vacuum pump. Right? If you're doing experiments with air, the ability to control how much air is in a particular space is very, very useful. And so the ability to remove air from a space, right, a vacuumed area, is very, very useful. And so it was this vacuum pump that allowed to have a complete vacuum to actually show that a coin and a feather would fall at the same rate due to gravity, and that the reason that a feather would fall more slowly is because of air resistance. So if you remove the air, it turns out all of these structures are being accelerated by gravity at the same pace, at the same acceleration. You hopefully remember from last year Boyle from his one of his gas laws. Boyle's gas law, P1 times V1 is equal to P2 times V2, and we will use this when we get to the gas laws unit, right? And so what I want to point out here is this thing that we use came from a hobby. Doing what you love and studying what you love as your ability allows you to. Now, this was a hyper-intelligent man. He had great ability. He also had the financial capacity to carry out all these experimentations, which other people didn't, which is true. But this person just followed what they were passionate about, right? One of the things he would do with his friends and his colleagues is they would go hot air ballooning. So learn about your hobby. You'll find out it'll actually cause you to be more in the moment, to enjoy that thing more. If you really love a sport, learn about that sport. You'll enjoy it even more, and you'll actually be able to help the people around you, and this person did in quite a significant way.